Imagine two massive towers of numbers standing side by side. On the left, we have 1000 raised to the power of 1001. On the right, we have 1001 raised to the power of 1000. Calculating these directly is impossible for a standard calculator, as the results would contain thousands of digits. Instead of brute force, watch as we apply a powerful mathematical transformation to shrink these giants down to size using logarithms. To begin the comparison, we take the natural logarithm of both values. The magic of logarithms lies in the power rule, which allows us to pull those terrifying exponents down to the front. Watch as the exponents float down to become simple multipliers. On the left side, we now have 1001 multiplied by the natural log of 1000. On the right side, we have 1000 multiplied by the natural log of 1001. At this stage, the comparison is still not entirely obvious. To see the relationship clearly, we need to separate the variables. Let us divide both sides by the product of 1000 and 1001. See how the terms rearrange themselves. On the left, the 1001 cancels out, leaving us with the natural log of 1000 divided by 1000. On the right, the 1000 cancels out, leaving the natural log of 1001 divided by 1001. Now notice the symmetry. Both sides are now expressions of the same underlying function, the natural log of x divided by x. To solve our problem, we simply need to determine if this function is increasing or decreasing for large numbers. We do this by taking the derivative. Using the quotient rule, we find that the rate of change is determined by 1 minus the natural log of x. This derivative tells us that the function reaches its absolute peak when x equals the number e, which is approximately 2.718. For any x value larger than e, the derivative becomes negative, meaning the function is strictly decreasing. Visualize the graph rising quickly to a peak at e and then slowly sliding downwards forever. Since both 1000 and 1001 are significantly larger than e, they are both located on the downward slope of this curve. Because the function is decreasing, the smaller input yields the larger output. Since 1000 is less than 1001, the value on the left is higher. Tracing this logic back to the beginning, we can definitively say that 1000 raised to the power of 1001 is the larger number. If you enjoyed this explanation, hit subscribe and check out our other math videos.